Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to continue our discussion on geographic distributions by transitioning away from how we measure the center of a distribution to talking about how we can measure the variability. Or put another way, how dispersed the points are in space. And one of the ways that we can do that is through what's called the standard distance, right? Standard distance. And so what standard distance is going to do for us is it's going to give us a single value that represents sort of the average distance away from the central feature. Or I guess technically, to be specific, standard distance is usually measured using the mean. So it would be the distance from the mean. And you can think about this, as we'll look at the equation, in much the same way as standard deviation, right? That's why you see this standard here, right? This is very similar to the idea of standard deviation, where you're going to get a single value that roughly represents the average distance away from the mean. Well, standard distance is going to be a number that roughly represents the average distance from the mean center. And the way we can interpret this, right, is that higher values of standard distance relative to the data is going to mean that the data is more dispersed, right? That the points are farther apart than lower values of standard distance. So let's go ahead and look at the equation. And again, this is going to look very similar to the standard deviation equation. So hopefully you can see the similarities as we draw them. Right, but standard distance, we'll see that SD for standard distance is going to be equal to square root, just like we've seen so many times before. But what's inside of the square root is going to be the summation of x sub I minus x bar squared over n. Right, and then we're going to add to that the summation of y sub I minus y bar over n, and that top piece is squared, right? So this right here, this is the equation for standard distance, and you'll see that it's very similar to standard deviation, right? Because again, what we're doing is for any given point, we're subtracting the mean from whatever that x-coordinate is, squaring it, summing those up, dividing by the total number of points. And then we're adding to that the exact same thing but for the y-coordinate. And then we're taking the square root. Okay? So again, what this gives us, right, you can think of it based on these two pieces here, right? You can think of it as the average distance, right? Because this piece, this top piece here, this is the equation for Euclidean distance, right? We're dividing it by the numbers, so we're getting the average, right? This is basically the average distance away from the mean. Okay, that's what this sort of largely represents, right? This is a measure, right? It's not the exact measurement of the average distance, but it's a measure of the average distance. Right, it is a measure of the average distance from the mean. Right, that's kind of what this is a measure of. And so we've already calculated in previous examples using this data set, right? We've already calculated the mean center as roughly 5.336. So I'm going to try and put this in. 5.336 is going to be like roughly right here. Right, so we know this is the mean. Okay. So let's go ahead and look at this equation for standard distance in Excel, because there's a lot of pieces here. So rather than doing them all by hand, let's go ahead and look at them in Excel. Okay, so here we have an Excel spreadsheet, And in this Excel spreadsheet, we have our points. So these are the same points we've been dealing with the entire time over here. I went ahead and I calculated the mean. This is the same mean that we've seen before, right? 5.33 and 6. Okay, so this should all be reviewed. These two columns right here represent that first piece of the equation where we took whatever the x was for that coordinate and subtracted the mean, right? So this x minus mean. So this cell right here, for example, is this 2 minus 5.3. Right, this would be this cell right here would be this 10 minus this 6, right? So that's all this is doing here. This is taking whatever the x coordinate is and subtracting the mean. Okay, that's all that these two columns are doing. Then over here, what we're doing is we're taking that value and we're squaring it, right? So if we remember that equation, right, the equation was x sub I minus x bar squared. So this is xi minus x bar, and this is squared. So we're taking this number and we're squaring it. That's all this is doing. Then we're summing them, right? Because again, the next step was to take those differences squared and sum them. So this total right here, this is just the sum of these. So we can add these up and get this number here. Same thing with the y's, right? We're just adding these numbers up to get this number here. Then, so we have the total summation, and then the next thing we had to do, right, was to divide it by n, right? Because it's x sub I minus x bar squared summed divided by n, right? So this is dividing by n, right? Our n in this case is 6. So this number here is just the total, right, divided by 6, right? The total divided by 6 for the x coordinate, and the total for the y coordinate divided by 6. Okay, and then we add them together. All right, so that's this plus this, and then we take the square root. Okay, so all this, these columns and these summations, this is just a step-by-step approach to get this value right here. So this 4.26, this right here is the standard distance, right? So this 4.268 is the standard distance for these points, which again is an estimate of an indication of the average distance away from the mean center. Okay, so we'll say 4.27. Okay, so let's go ahead and hop back over to our paint. And let's go ahead and record our standard distance value. We said we'll use blue, right? Is 4.28, we said, right? So this distance right here is our standard distance, which is an average distance from the mean. So typically what you will see for standard distance, the way standard distance is typically represented, is by using this distance as the radius of a circle. Right, this is a value measuring the average, a measure of the average distance from the mean, but we typically represent it as a radius of a circle. Right, so what we would do is we would start at the mean here, and we would go out approximately 4.28, and then in all directions, right? Because a circle is defined as a set of points that are all equally distanced from the center. So we would start at the mean, and we would go 4.28. So this is 5.3. So we would go to plus 4. It's going to be 9.5 roughly. So we'll say right here. This is 6, so we're going to go up to 10.25, which we'll say is like roughly right here. And I'm going to butcher this, but you can imagine, right, drawing a circle. Right, so 5.3 minus 4.28 is going to be just over 1, so it should be like roughly right here. And again, right, I'm butchering this with my hand drawing here, but you can imagine that we've created ourselves a circle around the mean, right? This circle, right? This circle has a radius equal to the standard distance. So in this case, this circle has a radius of 4.28. coming from the standard distance, right? And again, to sort of recap, what would happen is the larger the distance, right, the more the points are spread out across the area, right, the larger the standard distance would be, the greater the radius of the circle would be, the larger the circle would look when you look at it on a map, right? So that's kind of how this works. The more distributed the points are, the larger the standard distance is, the larger the radius of the circle is, the larger the circle ends up being on the map. And that's how you can interpret standard distance, right? Relative to the data set, right? Standard distances are going to give you a way of visualizing, right, with a single polygon, right, the distribution of the data. So hopefully that made sense. Hopefully this idea of standard distance and the way we describe it as a circle makes sense. And as always, if you have any questions, please reach out. Thank you.